Hey friends, here's a company you might not have heard of. This episode is sponsored by our friends at Scale-Out Software. They're an industry leader in distributed caching and scalable in-memory computing for .NET. Whether you're building apps for e-commerce, financial services, or IoT, you've got to track large volumes of fast-changing data to quickly get answers and keep your business at the cutting edge. With innovations like coherent caching across cloud availability zones and real-time digital twins for streaming analytics, Scale-Out Software provides the technology you need for a competitive advantage. Learn more about Scale-Out's cool in-memory computing technology at scaleoutsoftware.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Chris Sells, who's a PM on the Flutter team at Google. How are you, sir?
I'm good, man. How are you?
I'm very good. You've been on the show before, but I want to say it was several years ago, even longer. We've known each other a very long time.
Yeah, it has been a long time. It's been too long. I just celebrated 7 years at Google, and when I came, I was like, I'm not going to do any Windows stuff. I'm gonna embrace all of the Node things and Macintosh, and it turns out I couldn't help myself. I've done a number of Windows projects over the year in both cloud and now here on Flutter. So thanks for having me. I appreciate it.
Yeah. So to set a little bit of context and why it's interesting to talk to you, we're going to talk about Flutter. We're going to talk about the technology and the new announcement for stable Windows support. But I want to read episode 263. This is 400 episodes ago from April of 2011. This is the description of a Chris Sells interview. Scott talks to Chris Sells. Chris has been up since 7 a.m. writing JavaScript and HTML. What is the world coming to when one of their foremost managed code experts starts writing code for the web? How is he finding JavaScript and what should you do about it? That was April of 2011. So 11 years ago when you discovered the internet from a coding perspective. And now you're here talking about how to write Flutter apps with, all these things. So do you remember that at all?
I do remember doing that coding. In fact, I spent a bunch of time doing HTML and JavaScript, and I remember going through the whole 5 stages of grief with JavaScript, eventually ending up in acceptance. Although today maybe we'll be talking a little bit about how Dart and Flutter, especially on the web, are kind of denial of HTML and JavaScript. But I don't remember, what did we end up talking about? I don't even remember. 11 years ago, what did we even talk about?
We were going through the differences in the relationship between unmanaged code in engines and platform-specific code, and as you move up the layers, the differences in responsibilities and the kinds of things that you think about. And the reason that I bring that up is I think it's interesting for our friends who are listening if they go and learn about Flutter and why Flutter is interesting, and they look at the architectural layers of Flutter, talk about Dart and C and C++, and then the embedder at the platform-specific layer. That was really interesting. And what I think is great about you is that you now have, this full stack, truly full stack, from the metal, from the silicon, all the way up until the pixels show up on the screen. You've got a really interesting perspective, both as a developer, but also from a historical context perspective of how something like this gets built. So let's ask you this. What's the problem that Flutter is solving for the average developer?
The interesting thing that has been happening in the industry for years and years, which is that, across the various kinds of ways to build apps, things have been homogenizing, right? If you look at mobile, Android and iOS, they borrow features from each other all the time, and they're constantly because of the beauty and wonder that is competition, they're trying to make sure that they all have all the features, right? So from a capabilities point of view, they've been getting closer and closer over the years. You look at the web browsers themselves, right? Trying to provide a great experience over the web. They've been getting closer and closer in functionality and capability over time. And likewise with desktop operating systems, right? I mean, of course, Linux has been trying to keep up with Windows and Mac for years and years. And I was super surprised the other day when I installed Windows 11, and wow, it sure felt a lot like Mac OS from a shell point of view. So that is interesting. The other thing that's interesting that's going on is that the platforms themselves are borrowing from each other, right? The desktop operating systems are getting access to cellular radios and, cameras, and they become more and more like devices. Mobile devices operating systems are growing up to work on devices with keyboards and mice on them and bigger screens, and everything, from a kind of a 2D interact with the user point of view is all coming together to have one kind of set of capabilities and properties, which makes it, for the first time, I mean, for 30 years in our industry, we've been trying to build a kind of a universal front end UI toolkit. So you can build your front end apps in one way and then deploy them however you want. You want to deploy them over the web, you want to deploy them to the phone, you want to deploy them to Windows, whatever, right? Whatever you want to do. It's now a lot more possible because these platforms are a lot more similar to each other than they've ever been. So we're at this magic time in history, in our industry, where the devices and the capabilities are coming together. At the same time, Flutter comes into that environment with a modern UI toolkit, a declarative, reactive, composable UI toolkit that has learned from literally decades of how you build, UI frameworks and app frameworks, and it is attempting to be able to provide a modern UI framework that's optimized for two very different experiences. One experience is for the developer. How do we provide the best possible experience for the developer? And then the other experience is for the user. How do we give them a native user experience with, fast scrolling and jank-free animation and smooth video playback and all of those high kind of native performance kinds of things. And it's trying to bring all of that together to provide one UI toolkit where you can build an app and then target it at multiple platforms from a single source code base. That's what Flutter is trying to do.
Yeah, and you point out something interesting that we are seeing a convergence, a mobile desktop convergence, where you can put a Mac, you can put an iPad, pair it with a mouse, and suddenly now you're
Right.
moving your touch thing around. But also we're seeing things from the mobile environment like privacy controls, location, GPS pop-ups that say, do you want me to let you use my location? Even things like gyroscopes and am I moving the tablet?
Yeah, for sure.
It's blurred the line. So in the past, when we've written write once, run anywhere type applications, they've been filled with runtime checks, or we maybe would if-def our way to glory, where we would feel like we were writing once and running everywhere, but we weren't really. But you think that the underlying kind of like abstraction layer, the abstract interface that we talk to, we'll just say PCs, because everything's a PC now, even my iPhone, right?
Sure.
You're saying that it's happening. Like this is the moment where we can write an application and have a great experience on my big 4K monitor or my pocket supercomputer.
So you bring up an interesting point too, which is that while these things are homogenizing from a capabilities point of view, there are still things that are fundamentally different about the individual devices. For example, the anything you put in your pocket, even if you call it a pocket supercomputer, the way you interface with it is different. It's going to have a smaller screen. You're going to want to touch it until you connect it to a keyboard and a monitor and a mouse. It is a very different experience than, your laptop, but not from a underlying platform capabilities point of view, but from a how do you interact with the user point of view. And so what you want to do, the web for a long time has had this idea of responsive apps, right? If it's small, you do the navigation and layout of your content one way, and if it's big, you never know if your web app's going to be running on a phone. You never know if it's going to run on a desktop, right? So you want to be responsive. With Flutter, we don't use the term responsive. Because that kind of means a web kinds of thing. We use this term adaptive, right? If it's platform adaptive, where if you've got mouse input, it does a good job. If you've got keyboard input, it does a good job. You certainly want to adjust the layout and the navigation based on the screen size. So you want to be responsive in that way. But you want to provide based on the environment you're in. So instead of saying, hey, am I on a phone? Instead, you'll say, how big is my screen? Right? And how do I take maximum advantage of that screen? Instead of saying, hey, is this a phone? I want to take touch input. Instead, you say, hey, I've got some touch input. Let's do the right thing. And it could be a touch laptop. It could be a phone. You never know. Right. So it's all about the capabilities of the environment you find yourself in and not writing platform specific code as much as possible. Now, having said all of that, there is a layer of your application where you want to say, I do want to do some platform specifics, right? For example, accessing the camera on Android and iOS, these are very different APIs, very different. I mean, it's different languages that you write this code. And so with Flutter, you can always drop down to whatever the native platform is underneath. You can always write Java or Kotlin if you're targeting Android, and Objective-C and Swift if you're targeting iOS, and et cetera. You can always target the native platform, but it's at a certain layer, which means that you can write the bulk of your application to be device-specific agnostic. And then at the right layer, you can say, okay, now when we get to this part where we're handling the camera, then we, of course, do, the native things. And the beauty of that way of encapsulating things is most of the time, the individual developer doesn't even have to write that code because it's already been packaged into a reusable component that you can drop into your app. And then there's Android code in there, and there's iOS code, and there's Windows code in there, and the compiler sorts it out, and you can just write your Flutter code against it, and the right thing happens at the right layer.
Mm-hmm. So things like cameras and geolocation and the stuff, that's all understood. I say I want a camera component, and that flows all the way down, and you'll do the right thing, and the permissions and the privacy is appropriate. But let's say, for example, I wanted to write an application that talked to a custom barcode scanner. Now I've got to make platform-specific calls. I would go and write that for as many platforms as I would want to understand, and that would happen at that. I think it's called isn't there a channel host or platform channel?
Yeah. So what there's really two ways to get to the underlying operating system, the features of the underlying platform. One is essentially every Flutter app is a native app, right? Essentially, so you've got at the bottom it's an Android app or an iOS app or a Windows app. And what it does is, it's essentially, at the very least, it bootstraps your code, right? It loads your compiled Dart code and jumps into the first instruction and sets up the visual environment and IO, et cetera. It sets all that up and then runs into the Dart code and lets the Flutter app take over. But you can always put platform specific code there. And then the way you communicate is with platform channels. You're passing messages back and forth between your Dart and Flutter code and your Java or your C++ or your Android. That's one way to do it. The other way you can do it is we have a foreign function interface implementation in Dart that's very full featured, where you can just load up and call any C-based library, no matter what language it was built in. If it has a C-based language binding, you can make calls, you can pass data back and forth. So in a lot of ways, in fact, Tim Sneath, a mutual friend of ours, you and I have had lots of conversations and interactions with Tim Sneath over lots and lots of years. He has built a whole Win32 interactive library, right? So it actually uses this foreign function interface in Dart and to call literally thousands of Win32 and COM and WinRT APIs on Windows. So you can just write Dart code and it goes directly to the underlying APIs, and there's no message passing, and you don't have to write any native code. You're just calling these existing APIs.
Okay, so then to put that into the context of some of our listeners who may be .NET developers, that's like P invoke, right? It's like a binding.
Exactly.
It's a nice layer, interface layer.
That's right.
At the end of the day, your customer has to be at the center of everything you do. This starts with the right customer data strategy, as well as the right foundation to solve the challenges that typically inhibit the success of your company, such as data quality, data governance, and connectivity. mParticle is your real-time customer data infrastructure that helps you accelerate your data strategy by cleansing, visualizing, and integrating your customer data from anywhere to anywhere. Ultimately, better data leads to better decisions, better customer experiences, and better outcomes. See why the best brands choose mParticle. Go to mparticle.com. That's mparticle.com. So one of the things I want to try to dig into a little bit for our earlier in career developers, because I think sometimes people get confused about this term native, and sometimes native is used as a marketing term.
Sure.
And this is just for understanding, no disrespect to any of our friends that we're going to talk about. If you say something like React Native, I've heard people write like React Native enables native-like mobile applications, and someone will say, no, it's truly native because you're using native controls. And then other people will say, well, no, there's a web view involved, or no, there's an engine involved. What does a native app even mean anymore?
Yeah, that actually we struggle with that ourselves, right? Because when we communicate, we want to be as clear as possible. I mean, obviously, marketing is letting people who are in your target audience know that you've got a thing that might solve their problem, right? That's fundamentally what marketing is. And developer marketing is doing that without lying to anyone, right? So we try to do both of those things for sure. And we use the term native because, well, so for Flutter, what that means is we compile down to x86 instructions or ARM instructions depending on the platform. Except on the web, of course, we generate highly optimized JavaScript, right? I mean, so we're compiling down to what the native instruction set is for the environment.
And you're doing that a priori. You're not doing that JITted.
It's funny. We talked about that kind of two things we optimize for. During development, we do JIT it. It is just-in-time compiled so that we have hot reload instantly. You turn your head and boom, you're looking at an updated version of your app, right?
Cool.
That's all JITted, and that to support hot reload. But for end users, right, when you release your app and you put it up on the App Store or you put it up on your website, that's all ahead of time compiled.
Okay, so that's a good definition of native from I'm running my for loop and it's in native instruction set.
That's right. So that's one definition. Another definition could be I'm using the UI controls that are provided out of the box with the platform. Flutter doesn't fit that definition of native. Flutter provides its own implementation of the material design language. It provides its own implementation of the Cupertino design language. The Flutter community has provided one for macOS, and they provided one for Windows, the Fluent design language. What you can do in Flutter is you have so much control over the pixels, the way things look and feel, is that you can build out these design languages and make your app look and feel, however you want. You can make it match the underlying platform if that's what you want, or you can you can build up a theme and make it look the same no matter which platform it runs on, and you have that choice with Flutter. But what it does not do is it does not use the underlying UI widgets that are provided with the platform itself.
Interesting. And one may or may not care about that kind of stuff. The reason that I ask is that, many years ago, and I think you and I were there, or at least nearby each other at the time, and I was like 1990, working at Nike doing Java. I was writing Java that ran on X Windows. I ran on hot Java machines. And
that's right.
They all looked the same because they painted the same pixels. So what was not awesome about that is you could tell it was a Java app everywhere. It didn't feel like a Mac app. It didn't feel like anything. It was just what they call owner draw.
Right.
But Flutter apps are known for looking good everywhere. They look like Mac apps on Mac because they're Mac apps, right? So you've gone out of your way to make them look good.
Out of the box, we provide two design languages, Material and Cupertino. And we have done, blind taste tests, right? Hold up, different apps built differently for the same platform. Can you tell the difference? If you can tell the difference, then that's a bug. That is something for us to fix.
Interesting.
And we have built the scrolling physics in and the animations and, pull to refresh and all of those things you expect for Android and iOS that makes it feel native. We've built, right? It was funny. We gone back to the original. Of course, we work very closely with the Android team, and so we re-implemented their same scroll physics, and we checked it with them just to make sure that we got it right, that we were doing their same physics with them.
So it sounds like that idea of what is native philosophically outside of Flutter, but just generally, is really blurry right now, because that people have pointed at Chromium apps or pointed at Electron apps. And there was a time, maybe a couple of years ago, when someone might look at an app with some kind of disdain and they go, wow, that's just
Sure.
it's always bad to say just in front of
Yes.
a huge amount of engineering work. When someone puts a great deal of work in front of something, don't put just in front of that. But they'll go, oh, well, that's just a... Should we care anymore? Like, does it really matter if it looks great and it acts great and it is native? It's native, or are we mincing words too much?
Here's the funny thing. I mean, again, we work closely with the Android team, and there are still cases where you want to build native Android apps. You want to take maximum advantage of whatever the resources are on that machine or those device or that device type. And of course, in that case, you're building multiple code bases for multiple devices, but you can have every raw bit of resource that gets to that. But eventually, you get to a point where I always tell people, right? What is that point for Flutter? And the answer is always you should try it, right? If you can build your app and it feels good on the range of the devices for the set of users that you want, that's what we think of as native. And so for us, it's not just we're generating x86 instructions, not just that we've duplicated the physics and the widget set as much as we possibly can, but we've tuned it so that it runs at whatever. If your device is 60 frames a second, we'll run at 60 frames. If it's 90, if it's 120, though, that's the speed that we will be running at. And if it feels good, if it feels right, then that's about almost as close to a definition of native that really matters.
Yeah. Yeah. Which brings us to some exciting news that Flutter 2.1 now includes production support, quality support, stable support for building Windows apps. I understand that you've been able to build Windows apps for a very long time. It sounded like you really waited to make sure that you felt good about it before you blessed it, because I know that you've been able to write Flutter apps for Windows for a while, right?
Well, so let me back you up. It isn't 2.1. It is actually 2.10. That trailing zero matters, which not your fault, of course.
Never heard of that.
It's a fairly silly naming scheme for sure.
Well, I do work for Microsoft, so I know what silly naming schemes.
Fair enough. So we went 2.0, and then I think we did 2.2. And so the last one was 2.8, and then this one is 2.10.
Okay, cool.
But of course, the bulk of what you said is absolutely true, right? Which is we have released Windows as stable. So if we have multiple channels of bits that you can consume for Flutter, you can be on the main branch and get multiple changes every day. You can be on the beta and get them essentially about once a month. And then stable is the version that this is the bits we have in production quality. So we release those about once a quarter, and it's a big release announcement for us. Sometimes it goes along with events and et cetera. And with the 2.10 stable, we released Windows into stable. And you're right, we have for a couple of years now actually had Windows, Mac OS, and Linux support in varying degrees of doneness for people to build desktop apps. And this has had a couple of things that people do with this. One is they have been building brand new desktop apps. And of course, a desktop app, you have a bigger screen size, you have, sometimes touch events, you've got, mouse events and touchpad and keyboard and all of those kind of desktop-y things, as well as, because it's Flutter, right? You can always write native code. So you can do like menus and integrate with the menuing system and all of that goodness. And people have been building apps and they've figured out, okay, how do we produce native XEs? Which of course that is on Windows, we produce a .exe file and some DLLs, and you bundle it up and you can send it as a zip file. Or we've got some folks in the community that essentially take some extra metadata and will produce an MSIX file, which you can also hand directly to your users. Or, we don't actually know the numbers. Maybe you could help me find these out, Scott. But hundreds or thousands of these apps have made their way into the the Windows Store, right? The Microsoft Store.
Yeah. And you pointed out that you support design languages around Fluent and around Cupertino, but there's also Flutter favorite packages. They're kind of like blessed or good, starred
Right.
by the Flutter team themselves, like Fluent UI and Flutter Acrylic. So you can use the Microsoft Fluent design system
That's right.
and look at those and say, wow, that's a gorgeous Windows app. Put it in the store, and then non-technical parent doesn't know or care. They just know they got a great app out of the store that looks like $1 million on Windows 11.
Well, that is the whole point, right? That you can use the magic of Flutter, which from a developer point of view provides all kinds of productivity, but it also provides access to all these amazing kinds of facilities, right? That Flutter apps, as you mentioned before, tend to just be better looking in general. They have all these cool kinds of things you can more easily do in a Flutter app, but then they run at native speeds, right? They're compiled to x86. Well, actually, sorry, they're 64-bit. We only do 64-bit.
Yeah. x86, you're saying, is a shortcut. Yes. You're saying native true machine code.
That's right.
And I do want to also point out, just as a point of fun here, I know that everyone appreciates the sound quality enhancement. It was never our intent for Chris to come on with a cold and someone mowing his lawn and fixing his house all at the exact same time. But that's just the kind of dedication that you have to sharing to the developer audience what's going on. So I do appreciate you doing that. Yeah. So architecturally, I just want to, as we get towards the end here, have people understand the architecture so that they can go and explore writing their own great Flutter apps on Windows or on any platform. There's the framework language is Dart. Now, explain the relationship between Dart and JavaScript and TypeScript and these other kind of Dart-ish language. What is Dart?
So Dart is, it started its life at Dart 1.0 was kind of dynamically bound, right? Which meant that it was very much a scripting language. And it started as a web language, right? As a potential replacement for JavaScript. And for a while, there was even an experimental Dart VM that was built into the Chrome browser, although that's long gone. And now, as of Dart 2.0, it's statically bound, right? So, the compiler will tell you did it wrong, and it has all the type safety features that you would expect. And it's got all the language features you'd expect. It's got classes and extension methods, and it's got null safety and async and await. And it looks and feels like any modern C-based programming language. It's so that said, that Dart language still, for example, Angular Dart, we have 10 years of experience generating JavaScript from Dart, highly optimized JavaScript that we ourselves at Google use for several important apps. We have literally thousands of Angular Dart developers at Google, and part of that Dart to JS comes out if you start building web apps with Flutter, right? You write your app in Dart and it generates the JavaScript. But mostly, if you're running a mobile, it generates ARM code. If you're going on the desktop, of course, it generates 64-bit x86 instructions.
Yeah, that's interesting. That sounds like one of the, as pivots go, that sounds like a dramatically successful pivot. Because like you said, in 2011, thinking, maybe this will be a replacement for JavaScript, because we all know that JavaScript isn't the language that we deserve, but it's the language that we have. So there's all these different...
It's not the one we want, but it probably is the one we deserve.
It's very much the one we deserve.
Yes.
And then TypeScript is a superset of JavaScript, so it transpiles. Dart transpiles optionally into JavaScript, and it's a C-based or a curly braces related language. So as a curly brace person myself, it seems quite comfortable. It doesn't seem like it's anything where it would slow me down. Like the idea of I got to do a whole new language. It seems like Dart is pretty comfortable for anyone who's got any kind of curly brace familiarity and object-oriented understanding.
For sure, as well as it being optimized for client side. A lot of you definitely can use Dart on the server side, and people do. People build server side code, and there's all kinds of things to enable that. But it is very much optimized for building client-side code, which means that the kinds of decisions we make about Dart and the features are client-side first. And kind of Dart and Flutter have really grown up together to support each other. And in fact, when we moved, from dynamically bound to statically bound, that was a big deal. But then recently, at the beginning of last year, we added in null safety and tight sound null safety, which means that if everything in your code is null safe, then all of that compiler goo to check nulls and et cetera just falls away, and your code gets smaller and faster. And of course, because you've taken null out, your code just gets better. So it's like a triple win. That was a big shift too. That one was immediately adopted, right? The numbers across the board in terms of developers. Almost every Dart developer at this point is using null safety. They universally love that. And that was a huge shift.
Very cool. And you said it's a triple win, which is a very good way to end, because Flutter itself is a triple win: mobile, web, desktop, and even, I guess, embedded apps, all from a single code base. So folks can check it out at flutter.dev. They can get the latest 2.10.
That's right.
And they can do that on Windows, on Linux, on Mac, and even on Chrome OS, can't they?
Yes, for sure.
Very cool. Well, thanks so much, Chris Sells, for chatting with me today about Flutter.
It was my pleasure. Thanks for having me, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.